Okay, so I go in, I grab the source code, I add my own components to it, but since I'm not making money out of selling it, I just want to release it up to the internet so other people can see what I have done so far and add on top of my work. So the product will just get better and better with more and more features because every person who comes along to extend it will also release it back, quote unquote, in the wild so that other people can add on top of that. So we are all standing on the shoulder of giants, and the giant is getting bigger and bigger. Okay. Any other questions related to the remote thingy? But you guys saw how we turned a laptop computer into a Microsoft Surface, right? All he did was to flip a laptop computer so the screen is flat on the desk, and he used a Wiimote to look at the screen from above, and that's all he did. Now I know a 15-inch screen is not nearly as good as a 30-inch screen. But if a 42-inch high-definition TV is only about $400 or $500, you just buy one, you lay it flat on a table, you hook up your HD TV to a computer, to a laptop computer, and now you have a touch surface that is probably big enough that you will have problem reaching to all the corners because a 42-inch TV is actually quite big already.
Is it just connected via USB?
That's the interesting part. The Wiimote is a Bluetooth device.
Oh.
Yep. So you do need to get a $10 Bluetooth to USB dongle so that your computer can talk to Bluetooth. If it does not talk to Bluetooth, like a laptop sometimes already has built-in ability like that. Yeah. So it's quite interesting, what people have done with a Wiimote. A device seemingly so simple, already has all these capabilities. And how old is the Wii? When was the year that they first came out with the Wii?
2006.
2006? So it's actually a pretty old product already by today's standard. All right, so let's go back and talk about the more kind of boring stuff. But since you mentioned Microsoft Surface, I just wanted to show you guys how to make your own Microsoft Surface for nothing more than the cost of a Wiimote. But you guys already have many Wiimotes, right? So it doesn't cost you anything. Yeah.
What about a projector? Cost you that?
But you don't need a projector. You can use a screen. You can just use a flat screen as the surface because all it needs is to have a surface to reflect the light from the light pan. The light pan that you mentioned, they are not going to work here because you need an infrared light pan. It is not visible light, it is infrared. So what you need to do is you can hack one of the light pans or that you can buy from a store, replace the light emitting diode, the LED, with an infrared type. You might need to adjust some of the other things so you limit the current the same way. But you can make it happen pretty inexpensively. So I just thought, this is interesting, especially, for high schools these days, which do not have a whole lot of money to buy, the Promethean board and all kinds of, high-tech stuff. This is an easy way to put an interactive whiteboard into a classroom. Okay, so let's get back to where we left off last time. And according to the video clip, we just got started with the top-down design topic. And I can just go over what we talked about last time, and then we will continue from that point. This is where we left off last time. Last time we finished up the code enough to include the loop itself while n is greater than 1, which means as long as the number can still be factored. Because when n equals to 1, n is not a prime number, and n cannot be factored anymore. The first thing we do inside the loop is to find a prime factor f of n. Now this line is the key of this entire module, which is top-down design, because what we are doing is we are specifying what needs to be done, but not how to do it. Okay, that is going to be a very important concept in programming, because this way we can focus on high-level logic without actually having to think about the low-level details of how to make it happen. The next item is to print the value of f out to the screen, and the last portion here is to update n so that n is n divided by f. So this way, we move the number down one notch so that the next time we go over whether n is greater than 1, there's a better chance it is going to be less than 1. If not, we'll find another factor of n. Are we okay so far with this logic? It's good? Let's go ahead and trace it. I mean, we're not going to prove the correctness of this, because, proving the correctness of anything involving a loop is going to be quite painful. So what we'll do is we'll just go ahead and trace it to show that, it works in specific cases. And then we'll look into how exactly am I going to find a prime factor f of n. But we'll worry about that later. The first thing we do here is just to follow that code. So I'll just go ahead and type the whole program. While n is greater than 1, do find a prime factor f of n. Print f, n gets n divided by f, and while, and remember to use the correct indentation and line numbers. Okay. And remember to save the document. For some reason, I have problems creating new folders from inside here. Still don't know why that is the case. But I can do it outside. Alright, so now we have our spreadsheet. And then we'll do some tracing. There we go. Do we need a column for comments?
Always.
Well, in this case we do, because we have a loop. Why do we need a column for comments when we have a loop? Go ahead. Yep, because we need to indicate whether a condition is true or not. Line number we always need, and this time we have two variables. We have variable n and variable f. So we'll go ahead and make these a little bit smaller. Make them all fit on the screen. All right. Do you think we need to know something about n before we get started? What is the first axis of n? Am I reading the value of n, or am I overwriting the value of n? We are reading, okay? So that means n cannot be unknown, because otherwise I cannot say whether n is greater than 1 or not. That means in a precondition, n has to have a specific value. So let's pick something that has, two factors, okay? Something that I can factor twice, like 4. And what about f? What is the first axis of f? Am I reading something from f, or am I overwriting f?
You're reading something.
Nope, I'm overwriting. Okay, the statement find a prime factor f of n means that I'm overwriting the value of f so that it is a prime factor of n. Okay, so it is overwriting the value of f, which also means that f can start with an unknown value, because I'm not going to use that value for any purpose. I'm just overwriting f first before I use the value of f. Are we okay so far about the precondition of this trace? So this is showing you that sometimes we do need certain preconditions, and other times we don't need a specific precondition. It depends on the algorithm and what I'm trying to demonstrate. We have line 1 here. Line 1 is asking the question, n is greater than 1 is true. Of course it is true, because it is 4. So we go to line 2. Now, line 2 is a little bit hard. What do I do on line 2? Looks like I should be changing f, because I'm finding a prime factor, and I want to put a prime factor into f. Can someone name a prime factor of 4? 2. Very good. And on line 3, I print F. There's really no easy way to indicate that we are printing something out in a trace. So most of the time, I simply say, or I use the comment column to say that I'm printing a specific value. So in this case, what value am I printing? 2. Very good, because F has a value of 2. On line 4, I update n. N becomes n divided by F. N is 4, F is 2. 4 divided by 2 is 2. Very good. Then where do we go?
Line 1.
We go back to line 1 because this is a loop. Every time I'm done with the actions associated with the loop, I go back to the beginning and I ask the question again in order to decide whether I should be exiting the loop or whether I should go for another iteration. So in this case, I go back to line 1. What do you think is the condition? N is greater than 1 is true. Very good. So we go to line 2 again. What is n at this point? N is 2. What is a prime factor of 2? 2. 1 is not a prime number. Remember, 1 is not a prime number. Okay, so now we have F reinitialized to 2. And then we move on to line 3. Same thing. We print the value of n, which means we are printing the value of 2. We go to line 4 again. Line 4 is dividing n by f. N is 2, f is 2. 2 divided by 2 is 1. We update n. It is now 1. We go back to line 1. Line 1 is asking, is n greater than 1? The answer is false, and we are done. Okay? So if you look at what it's printing out 2 and 2. That is correct. 4 is factored as 2 times 2. So the algorithm works just fine. Are we okay so far about the overall algorithm? Now, once again, getting back to the topic of pre and post conditions, this is a trace. By no means am I claiming the algorithm is correct. All I am showing is when n equals 4, the algorithm seems to handle it just fine. But I have no idea whether it's going to work well with n equals to 11 or 21 or 99 and so on. Okay, so this is not a proof that the algorithm is correct. It is just a verification that it does work with one test case. Okay? Yep, go ahead.
About the trace.
Mm-hmm.
What does it mean exactly when you say print to?
It means that if you have a print mechanism, like if you can print to a screen, it will display 2 on one line at that point.
Oh.
Because I don't have a mechanism to trace what is going to show up on the screen. So all I'm going to do is to use the comment column and just say that on this line at this point I will print whatever value on the screen. Is that okay?
Mm-hmm.
Any other questions about this code? No questions about this code? Yes, go ahead.
What's going on line 4?
What's going on line 4? On line 4, the first time we got to line 4, which is here, we pick up the current value of n, which was 4, and we pick up the value of f, which was 2. And this is a division. The slash means division. So n divided by f, in this case, would be 4 divided by 2, which gives you a quotient of 2. The quotient is stored back into n, so that's why n is finally updated to 2 on line 4. Yep.
This is a top-down design?
This is in the top-down design module, yes. Yep.
Okay, I'm having a hard time understanding line 2. So find the prime factor of f of n. Is that a subroutine that's going to determine what to break it down and figure it out?
It is a abstract operation. Okay, if you want to, I can replace it with f gets a prime factor of n, which actually means the same thing.
Okay.
In other words, instead of saying this, which is the way I put it in the notes, I could use a more conventional